All right, so with these, we are looking at systems of linear equations in 3 variables. This is going to be similar to the previous section that we did, except there are going to be 3 variables instead of 2. We're going to solve by elimination, where we're going to reduce it down to two equations with 2 variables, and then solve it just like we did the previous problems. We'll back substitute into it. So our first example is determining if an ordered triple, so determined if the ordered triple, or an ordered triple, so it's like an ordered pair, except it has 3 variables instead of 2 variables. So determine if an ordered triple is a solution to a system. So we'll have a bigger system this time. We'll have x plus 2y minus 3z equal to 9, 2x minus y plus 2z is equal to negative 8, negative x plus 3y minus 4z is equal to 15. So we have 3 equations and we have 3 variables. But we're going to do things that are similar to the previous section where we did the solutions of a system with 2 variables. So what I'm going to do is plug in our value of the ordered triple we're looking at is negative 1 to negative 2 a solution for this system. So this is our x, our y, and our z. So we are going to have, for this one, we'll have negative 1 plus 2 times 2 minus 3 times negative 2 equal to 9. Well, negative 1 plus 4, negative 3 times negative 2 is plus 6 equal to 9. Well, this says negative 1 plus 4 is 3, 3 plus 6 is 9, 9 equals 9. So it works for this one. So let's try our next one. So we'll bring this one down here, and we'll have 2 times negative 1 minus 2 plus 2 times negative 2 equal to negative 8. 2 times negative 1 is negative 2. Minus 2. 2 times negative 2 is negative 4, equal to negative 8. Negative 2 minus 2 is negative 4. Minus 4 is negative 8. So that one works. And then we'll do this one right here. So we'll have negative 1 plus 3 times 2 minus 4 times negative 2 equal to 15. Negative times a negative 1 will get us positive 1. 3 times 2 is 6. Negative 4 times negative 2 is positive 8, equal to 15. So 1 plus 6 is 7. 7 plus 8 is 15, equals 15. So yes, this will work. If any one of the equations did not get a true statement, where the same number equals the same number, then the answer would be no. So that's doing an ordered triple. Let's go now and do our solving by elimination. So here is example 2, and we are going to solve by elimination. So here is our system. So we have x plus y plus 10z equal to 30. X plus y plus 5z is equal to 15, and x minus 2y plus 3z is equal to 27. So we're going to take our first 2 equations and we are going to cancel out one of the letters. So let's go ahead and cancel out, let's go with x. Let's go ahead and cancel x. So I'm going to leave this one, because it has bigger values, I'm going to leave it the same with no change and multiply the second equation by a -1. So this one will be no change, and this one we will multiply by -1. So first one will have x plus y plus 10z equal to 30, then -x minus y minus 5z is equal to -15. Well, our x's and our y's both cancel. 10z minus 5z will be 5z. 30 minus 15 will get us 15. We can actually solve for z here and get z is equal to 3. So we've got one of our variables. So now we need to pick two other equations, and we need to figure out what we want to cancel and what we're going to solve for. So let's take the first one and the third one. So I'm going to reset these up as x plus y plus 10z equals 30, and x minus 2y plus 3z is equal to 27. That way you can see completely what I'm doing. So I'm going to again multiply by -1 on the bottom part, because then I can get rid of the x. So this will be a no change. And this one will be multiply by -1. So no change, that just comes on over. X plus y plus 10z equals 30. And this will be -x positive 2y -3z equals -27. My x's cancel. I now have 3y plus 7z equal to 3. Well, now I have an equation that has a y and a z, and I know what z is equal to. So I'm going to sub in our z equal to 3 into this equation here. So 3y plus 7z is equal to 3. We'll have 3y plus 7 times 3 equals 3. Scooch that up a little bit. So we have 3y plus 21 equals 3. We'll subtract 21. 3y will equal 3 minus 21 gets us -18. Divide by 3, and y will be equal to -6. So now we can plug in or sub in. We already had z equals 3, and now we also have y is equal to -6. You can plug this into any of the equations. I'm going to choose the middle one because my numbers are a little bit smaller and everybody's positive. So I'm going to use x plus y plus 5z is equal to 15. So x plus that -6 plus 5 times 3 is equal to 15. So x minus 6, 5 times 3 is 15, equals 15. So 15 minus 6 will get us 9. So x plus 9 equals 15. We'll subtract out the 9, and x will equal +6. So our answer will be x, the y, and the z. It is an ordered triple, and the order does matter. So make sure you pay attention to which one is your x, your y, and your z. All right, let's go look at another example. So example 3, we have another system. So we have 5x minus 2y minus 4z equals 3. 3x plus 3y plus 2z equals negative 3. Negative 2x plus 5y plus 3z equals positive 3. So again, we need to eliminate one variable at a time in our equations. So if I take equation 1 and equation 2, and I want to cancel out z. Z will probably be the easiest one because I could multiply the second equation by 2, and I would have negative 4z and positive 4z. So those will cancel. Otherwise, I have to multiply by 2 numbers to get to something. So I'm going to do no change on the first one. And on the second one, I'm going to multiply by 2. So 5x minus 2y minus 4z is equal to 3. And then I multiply everybody by 2. 3 times 2 will get me 6x. 3y times 2 will get me 6y. 2z times 2 will get me 4z equal to negative 3 times 2, which is negative 6. 5 plus 6 will get me 11x. 6 minus 2 will get me 4y. And the z's will cancel. And it will be equal to negative 3. So I have an equation. I don't have another variable to plug in yet, so this one's going to take a little bit more effort. So now I need to choose 2 more equations. And I need to get rid of z again. I need to have 2 equations that have the same 2 variables. So here I've gotten rid of z, so I need to get rid of z again. So I'm going to choose these 2 equations. So I will have 3x plus 3y plus 2z equals negative 3. And I have negative 2x plus 5y plus 3z is equal to 3. So I'm choosing those last 2 equations. So if I'm trying to get rid of z, one of them I have to multiply by a negative, one of them a positive. This one will have to be multiplied by 2, that one has to be 3. So I'm going to do the negative on the bottom because that'll make that one positive. So this one here, the top one, I will multiply by positive 3. And then this one I will multiply by negative 2. So 3 times 3 will get me 9x. 3 times 3 will get me 9y. 2 times 3 will get me 6z. And negative 3 times 3 will get me negative 9. Here I'll get negative 2 times negative 2, which will be 4x. 5 times negative 2 will get me negative 10y. And 3 times negative 2 will be negative 6z is equal to 3 times negative 2 is negative 6. So 9 plus 4 will get us 13x. 9 minus 10y will get us minus 1y. My z's will cancel, and I have negative 9 minus 6 will be negative 15. So now that I have this equation and this equation, I have a system with 2 equations. So now I'm going to bring those down. I have 11x plus 4y equals negative 3, and 13x minus y equals negative 15. So again, I need to choose a variable that I want to cancel. I'm going to choose y, because if I do x's, I've got to multiply by 13 and I have to multiply by 11. But on the y's, I just need to multiply this one by 4, and I'll get negative 4y, which will cancel my y's. So the first one will be no change. And the second one, I will multiply by 4. So we have 11x plus 4y equals negative 3. 13 times 4 will get me 52x. Negative 1 times 4 will get me negative 4y. And negative 15 times 4 will get me negative 60. So 11 plus 52 will get me 63x. The y's will cancel, and it'll be equal to negative 63. I'll divide by 63, and my x will be equal to negative 1. So now that I have an x that is solved, I can solve for y. I can choose either equation right here to plug in my value of x. It doesn't matter which one. I'm going to choose the top one because my y value is positive. So now I'm going to plug or sub in x equals negative 1. So we'll have 11 times negative 1 plus 4y equals negative 3. So negative 11 plus 4y equals negative 3. We'll add the 11. We get 4y is equal to 11 minus 3 is 8. Divide by the 4, and y will be equal to 2. So I now have my x and my y. I need my z. So to plug in z, or to find z, I need to go back to my original system and choose any of the equations that are up here. It doesn't matter which one. I'm going to choose the middle one because my numbers are smaller than some of the other ones, and more of them are positive. So I'm going to choose the second equation, but you could choose any of them. So I'm going to sub in x equals negative 1, y equals 2, into any equation, but I'm going to do the second one. So we have 3x plus 3y plus 2z equals negative 3. So I have 3 times negative 1 plus 3 times 2 plus 2z equals negative 3. So 3 times negative 1 is negative 3. 3 times 2 is 6. Plus 2z equals negative 3. 6 minus 3 will get us 3 plus 2z equals negative 3. So now I just need to subtract the 3 from both sides, and I get 2z is equal to negative 6. Divide by 2, and z will be equal to negative 3. So now that I have my x, my y, and my z, my order triple will be negative 1, 2, negative 3. Again, make sure you put them in the right order. And you can always go back and take the order triple and plug it into your original equations like we did on the first example to see if the problem is correct. All right, so let's go on to example 4. So for example 4, we have another system. So we have x plus 4y minus z is equal to 20. 3x plus 2y plus z is equal to 8. 2x minus 3y plus 2z is equal to negative 16. So I'm doing the same thing here. I've got to figure out what I want to cancel. So I think my z's are probably easiest to cancel. I have a 1z, a 1z, and a 2z. And this one actually is negative, so that will be useful. So if I add the first two equations, I don't have to do anything mathematically except bring them over and add them together because I will have a negative and a positive z. So this will be no change, and this one will be no change. So we'll have x plus 4y minus z equals 20, and we have 3x plus 2y plus z is equal to 8. So x plus 3x will get us 4x, 4y plus 2y gets us 6y, the z's will cancel, and 20 plus 8 will get us 28. So we have one equation, we need a second one. I think I will take the first one and the third one because all I have to do is multiply this one by 2, and I would have negative 2z and positive 2z. So let's rewrite our equations. So we have x plus 4y minus z is equal to 20, and 2x minus 3y plus 2z is equal to negative 16. When you're doing these on your own, you do not have to rewrite the entire thing. I'm doing it so that you can follow what I'm doing, but you could just go ahead and do the multiplication. So the first one we're going to multiply by 2, and the second one will be no change. So this will get us 2x plus 8y minus 2z equal to 40. So I multiplied each term here by 2, and then no change, I'll add these over. And now I'll combine like terms. So 2x plus 2x will get us 4x. 8 minus 3 will get us 5y. And the z's will cancel, and 40 minus 16 will get us 24. So now I have an equation here, I have an equation here. So let's go rewrite our equations. So we have 4x plus 6y equals 28, and we have 4x plus 5y equals 24. So all I have to do is multiply one of them by a negative 1. This one has lower numbers than this one, so I'm going to multiply the second one by negative 1. So this will be no change, and this one I will multiply by negative 1 because that'll cancel out my x's. So we'll have 4x plus 6y equals 28, negative 4x minus 5y is equal to negative 24. So we just multiplied each term by negative 1. The x's will cancel. 6 minus 5 will leave us with 1y, and 28 minus 24 will get us 4. So we have the solution for y. Now we can sub that back in and find out what our x value is. And we can choose either equations. I will choose this one because the numbers are smaller, but you could choose either one. It does not matter. So let's sub in y is equal to 4. So we'll have our 4x plus our 5y equals 24. So 4x plus 5 times 4 equals 24. So 4x plus 20 equals 24. Subtract the 20 over. 4x equals 4. Divide by 4, and x will equal 1. So we found x. Now we can go find y. We found y, we found x. Now we can go find z. So we are going to sub in or plug in, either way, sub in y is equal to 4, x is equal to 1 to find our z. And again, you can choose any equation. I'm looking at, I need to find z. Out of the 3 equations, I have a single z right here that's positive, so I'm going to choose equation 2. So 3x plus 2y plus z is equal to 8. So 3 times 1 plus 2 times 4 plus z is equal to 8. 3 times 1 is 3. 2 times 4 is 8. Plus z still equal to 8. 3 plus 8 will be 11 plus z is equal to 8. We'll subtract the 11 over, and we get z is equal to negative 3. So now we're looking for our order triple. We have x at 1, y at 4, z at negative 3. And that's your answer. So let's look at another example. So we're going to solve a system with a missing term. So let's go ahead and switch. So we're looking at example 5, and we're solving a system. So solve a system with a missing term. So here's our system. We have x plus z equals 8, x plus y plus 2z equals 17, and x plus 2y plus z equals 16. So we've been given a little bit of a gift in the fact that we already are missing a y term. So we need to cancel out a y out of another equation, and then we can use this equation with the other one. So I'm going to use equation 2 and 3, and I need to cancel out y. So I could leave this one and multiply this one by -2, because then I would get -2y. So for this equation, we'll multiply by -2, and on this one, we will have no change. So we'll end up with -2x minus 2y minus 4z equals -34. And then this one just comes on over with no change. So -2x plus x will get us -x, y's cancel, minus 3z is equal to -18. So we have an equation here, an equation here. So let's bring that over. X plus z equals 8, and -x minus 3z equals -18. Well, I don't have to really do anything with this. I have an x minus an x, so I can just add this one. My x's cancel. I have -2z is equal to -10. I don't have to change either one this time. Divide by -2, and z will be equal to +5. So now I have z. I can plug z back into either equation. I'm going to plug it back into the original. So I can sub z equals 5 into x plus z equals 8. So x plus 5 equals 8. Subtract the 5. We get x equal to 3. So now I have z and x. I just need to find y. So now I can sub in z is equal to 5 and x equals 3. And I'm going to plug it into the second equation because I have a single y there. So x plus y plus 2z equals 17. So x is 3 plus y plus 2 times my z, which is 5, equals 17. So 3 plus y plus 10 equals 17. So I have y plus 13 equals 17. Subtract 13 from both sides, and we get y is equal to 4. So my answer will be x is equal to 3, y is 4, and z is 5. And again, it has to be in parentheses because it is an ordered triple.